the session. As I told you, let's so maybe if you already have the note, maybe you can also keep the note with you, because then you don't have to type. You can just copy paste and try these codes, so we can save some time, right? So the last time what we have discussed is the list versus the NumPy arrays. I have put some more details in the handout. Basically, list, you can have anything, meaning like you can mix data if you want, like you can have strings, integer, as well as floating point numbers in the same array, in the list. But when it comes to numerical Python arrays, it will be one data type. It should be one data type. It could be either integer or string and so on. And one thing I want to stress here, especially when you're working with a large matrices, make sure that you use numerical Python arrays, because it's more efficient. But for a smaller scale one, you can just simply use simple Python lists, right? Now, what we have discussed last time is, use of vectors. You can simply put it as a list. You can import NumPy as NP. I told you this is a short notation we will use, and then you can use a NumPy array, the library, and then this array method. And where inside this you put it as a list, right? And then we will discuss a couple of things: print in the list, as well as look at the type of the list. It will be NumPy LT array. And then you can get the length, the shape of the vector, and then size, and also accessing element. That part we have done. And the column vectors can be represented as a list of lists inside the NP array method. And then for each row we will have another list inside the list. So you can see it here. So this will represent the column vector. Now then we discuss vector generation functions, and in this particular case we discuss a range, like a range function, but it will generate an array of numbers. Same notation we can use as well, start and end. We said start, stop, and the second one we discussed start, stop, and step, right? The first one, the numbers will be print from 1 to 10. When you say 11, it goes up to 11, meaning like it will print numbers from 1 to 10. And when you have a third argument, then it will define the step, meaning like you start with 1, then you add 2, step you get 3. So likewise we discussed. Another thing that we have discussed last time is use of linear spaces. When you want to make a linear space between two numbers, start and end, you can make use of this. And there's a one point that we have discussed: when you want to exactly have the numbers, what you should do. So that also we have discussed. In this case, we have 50 elements. So if you want to have like 1, 3, 5, and so on, I think we have discussed we have 101. So let me import this library first. So this import library, and then so one thing we were discussing last time is, if you want to have exact values, so you can actually use it like this, or else we can start with 0 here, 0 and 101, which will give you perfect values. And when you have the 100, you will see comma, we put 100. Yes, so that will give you exact values. So in this particular case, so it is 100, and this should be 101 if I remember correct. Yes, this is exactly what we have discussed, right? Yes, exactly. Or else we can also have 1 and 100. We have 1, then this will be 100 points. we'll get these values, right? So that's about the linear spaces. So this is the thing that we have discussed the other day at the end, right? Let me continue from what we have done last time then. So today I'm going to look at now how to generate, matrices, right? So in this particular case, as we have already discussed, if you want to create matrices, so that will be set of, let me start with the coding window. So we can have a, here I'm going to create a matrix. So np.array. For each row, we can have a list of lists. So we know that square brackets represent a list. So each row we can have another list. So for example, let's say the first row, we can have 1, 2, 3, and so on. So like this one. And then we can have a comma. This is the second row. And then we have, right. So in this particular case, you will see it should be comma. When you run it, so we will get the matrix. So let's just print it. Print A will give you the matrix. So it's a 3 by 3. So you can see this whether it's a 3 by 3 by using the shape we discussed last time. So you can say a dot shape. It will tell you like exactly this will be a 3 by 3 matrix. And then the number of elements, we can say a dot size, right? And then the accessing elements, let's say I want to access second row and second column. So second row here and second column, which means we should get -5 here. So we know that the index start with 0. First of all, you can say print a within a square bracket. You can list the first you are going to have the row. So in which case we can say 1. And then once you have a 1, so that row, then you can get the third element, so 1 and 1. So this is one way of accessing elements. I will discuss more in coming sections. I will discuss. There are more ways of accessing elements. That part will come, especially the things that we have discussed earlier about slicing. So that also applies here as well. Right. Any questions from this part? As I told you earlier, you can always use the chat sessions. You can, stop me at any time, and then we can discuss. Right. So I will continue. If you have any questions, concerns, please let me know. The next thing I would like to discuss is generating matrices. Right. So when you say generating matrices, I'm going to look at a few more ways to generate. So for example, if you want to fill a matrix with ones, right? Or you want to fill the matrix with 0 with particular value. So for that, we have methods available. And then you will also have methods for, like, for example, generating identity matrices, generating random matrices, right? Again, I have given these details in the handout. So let me explain a couple of methods. Let me, I will start with the first one. First of all, if you, let's look at how to generate, vector. In this particular case, I'm getting a code being do, right? So I will start with importing this as np, and then you can use there's a question from Dr. Herat about how to send the print output and external printer. So there's no direct command for that, but you can always print this notebook. You can send it to printer, right? So this actually what I have done for the handout I have given to you, I did exactly same thing. I have converted this the notebook as a PDF file, and that then I have done some changes to adding heading. Otherwise, it will be the same. Now, same thing will happen here. So once we have a simple, let's say you do some calculation, you need the output, you can use the printer. So notebooks usually print as the whole notebook. So so otherwise, there's no direct way of the external print accessing. It's not possible with this. But you can also work with, there are some ways to do that if you need it. For that, we have to use some external libraries. Right. Dr. Herat, I hope you got an answer. Right. Thanks. Right. But if you're interested, maybe I can show you how exactly you want to do this, but it will be a bit complex. Usual way is, as I told you, like you use exactly as it is, and then you take the printout. Right. So here, if you just print np and ones, the method is called ones. If you want to fill everything with ones. So for example, if you put one value, it will actually generate a vector. Please note one thing you need to note here. So this vector, usually it's a floating point numbers. The data types, the data, you see this decimal point here. So which means it's the data type is the floating point. But if you, let's say, integer, then you can also have the modify this one. So maybe we can say, okay, print np.ones, you can say 5. Right? And then you can decide on the data type. So we can say, okay, data type, you can say D type equals int. You see the documentation shows here exactly how to do this. If you say int, and if you run it, hopefully we'll get integer value. So make a note of this one. This is sometimes important. Right. Let me show you column vector. So np.ones. Okay, now this time, for a column vector, you have to have two values, the number of rows, and you set number of columns as 1. Now, for example, if you put in this fashion, right, you get a column vector, and then you have 3 rows, right, and the values are in floating point number. So in this particular case, if you again need integer array, integer vector, column vector, so you can change the data type as int. So sometimes these things might matter to you, so that's why I actually shows you exactly how you may do it. Then the similar way, let's say we want to create a 2x3 matrix. Simply you can change the code. You can say print np dot, let's say ones, you can have 2 by 3. And then remember that this is a tuple. Remember we talked about the tuples earlier. So actually here we dimension put it as a tuple, right? So what is inside the dimension of the matrix, put it as a tuple, right? 2 comma 3, which will generate 2 by 3 matrix, which fills with zeros, right? Sorry, filled with ones, not zeros. So we start. If you need zeros, actually what you have to do is, I was trying to explain zeros, sorry. You just put zeros here. So zeros method will give you a matrix which is filled with zeros. Okay. And then identity matrices. So likewise, we can print identity matrices. So let me say the method is called I, and it will usually it's a symmetric matrix. So if you just put 1 is enough. So if you just put 3, right, it will be 3 by 3 identity matrix. So across the diagonal, the values are 1 and all the off diagonal elements will be 0. So here again, if you need it in integer, so you better put in here. Right, I made a mistake here. So when you have single value, you don't need to make it as a tuple. So I missed one bracket, sorry. Similarly, if you need random matrix, we can say np.random .rand. So within the random, there are different functionalities for coming up with random numbers. If you need the random numbers in a uniform distribution between 0 and 1, so you can use rand function. If you just put 3 by 2, right, in this form, you are getting the random numbers generated like this. But if you need like integer values, you might be wondering, like, let's say I want to have some integer values, then there's a randint method where you can use it. And then you can specify starting and ending value. Let me say I need the values in between 100, 1 and 100. So it will be like this. It will be just one value. If you need 10 values, we can say, okay, we can have 10. So I made a mistake here as well. It should be a single value. Then you will get 10 values like this. The values are in between 1 and 100. So to make a matrix for this, I have to teach you one other way. So in this one, actually, the randint will give you an array, meaning a vector, and then you can change the shape, right? You can change the shape. That is, we will call a reshape. So for example, in this case, if I put, let's say 10, and then if you put a dot, reshape 2,5, hopefully, yes, we will get like this. So what I actually did from here, from this part, I actually generate a vector containing the numbers, random numbers between 1 to 100, 10 numbers. Then I reshaped into matrix using 2,5. So the reshape method, which can be used for this purpose. In case if you want to use random integers, this is how you may generate a vector. Right. So any questions you will have, vector generation?
Sampath, if you run this again, do you get the same numbers or different set of numbers?
Yeah, just run it and see, it's different numbers. So actually what happened, madam, here, you will get random numbers. Every time when you use random number, you will get the random number. But if you want to fix, then you have to use a seed value, right? Now, let's say you are doing an experiment, and you every time when you run it, if you need the same number, same set of numbers, then you have to fix that.
No, but last time you got random row, you got, and then when you reshaped, you got the same numbers, right? That's why I asked.
No, okay. No, madam, it will be same numbers. No, it will not be the same number. It will change every time because it's depends on the timestamp usually. So maybe I can rerun and see. What you mentioned is only using this one, right? Yeah, let me check. So now we are getting 88. So it will change, madam.
With the reshape.
With the reshape, anyway, it's changing, madam. Now reshape.
No. When you
the
reshape the previous 10 numbers, the same numbers got reshaped.
Okay. Yeah. So the reason might be I'm actually using the previous one. That's might be the reason. But every time when you rerun it, it should give us a different set of numbers.
All right.
But in some experiments, we need now let's say we have a data set and we have to randomly take, let's say, 10 instances, 10 data points. So this is exactly what we are trying to use, this function. We can randomly draw set of points from the data set. Now, every time when you draw, then you will get a different data set because every time you get a different number, right? But sometimes we need to fix it. So then actually we can use some seed value. Yeah, you can actually fix. So when we work with the data set, sometimes you might need this because if you assume that otherwise what will happen, your output, the results will always change, right? So because of that, sometimes although you need random numbers, sometimes we have to fix those as well. Now, for example, if you want to fix it, now since we were discussing this, I have not planned this earlier, but let's say you want to fix this, then you put a seed value. So what you should do is you put np dot random dot seed, and then you can provide a number. So let's say 0, right? Then So hopefully we should, fix it. It's fixed now. Good that you asked that question. Now, what will happen? We will generate numbers, but we'll get a different set. So you can change the number, then you should get a different set, but now it is fixed. So when you are experimenting, sometimes the seed value is very, very important because we need random numbers, but we have to fix it. Otherwise, our results will vary at the end. So make a note of this because I have not put this in the handout. We will get to get the same set of numbers, set a seed value. Any questions before we move to the next one?
But that means the same set of numbers will be shuffled in a random way, right? Every time you run it.
So what we okay, so let me explain this with a sample. So let's say we have a set of data points, and then when we want to randomly draw 10 numbers, so then we can make use of random matrices or random number generations. So every time when you run a random number generation, you get different set of numbers. But what I told you here is, if you want to fix it, let's say every time when you draw, if you want to get the same set of numbers, then use a seed value.
Seed 1 and 2 means two different sets of same
Two
number.
different sets of numbers. Now, sometimes, madam, for example, especially when you draw different samples, we have to, let's say we do this repeat for 10 times. So what we should do is we should use different seed values for 10 times, and then maybe we will average our results.
10
Now,
seed.
yeah, with the seed, yes. So sometimes what will happen in packages, they automatically set this. Now, sometimes in a data sets, we normally separate our data set into 10 times, and we will rerun, and we will get average accuracy or something, or average statistics. So in those cases, the package itself set the seed value. Okay, are you okay with this part? May I move to the next one then? Maybe you can use the chat session.
Say we want to say the first year batch. We want to divide them into 50 groups. Okay. So how do you do it? Randomly.
Yeah, you can use, let's say we have 1 to 500 numbers, and
Yeah.
then you will say you need, 250. So it will draw 250 random numbers. And then you take the difference, then you get the next group.
Okay. Subdivide. Okay.
Yeah, many like, yeah, exactly. This is just an example, but if you randomly draw, yeah, so one way is you generate from, let's say 1 to 500, you divide, you will have 250. And then you can take the difference easily to take the next group.
Isn't there any way to do it in one go? Like 250, 550 groups means you have 10 in each group. So
Yeah, madam. Yeah, there are methods. There are methods now for particular purpose that you requesting. There are various libraries are there. You can easily do this in one go.
Okay.
You just put that, okay, these are the numbers, give us 2 groups, and then the function will give us 2 groups.
Okay.
Right. Okay, thanks. Then I'm not getting any answers in the chat, so I really don't know what to do now. Should I wait do you need more time? Okay, right. So the next part, let's say you have a very large matrix, right? Let's say I'm going to create the numbers from 1 to 10. Now creating, let's say 1 to 60. You don't have to. So we have talked about this earlier. We said range, right? Okay, so in this way we can actually have numbers. So a range 1 comma, let's say I'll put 70, right? So let me create a vector with np a range. I will put 1 to 70, and then if I print it, we know that it will print numbers from 1 to 60, right? And then at the same time, if you put a dot, and when you say a reshape, I told you this earlier. So let's say reshaped into 4 by 4, right? Then I will get a matrix where I have the numbers from 1 to 60, but it will be a 4 by 4 matrix. Right. Now, if you take, for example, the shape of the matrix, so we'll get it's a 4 by 4 matrix, so you will get that one. And if you want to print it, you have to say print x. Remember that. Yes. Right. Okay. Now, if you want to, access individual elements, I already discussed one method earlier, right? Now, let's say I want to access the element in third row and fourth column. So we know we have to say X. This is what I have discussed earlier. First of all, you put the third row meaning 0, 1, 2. Third row means the index is 2. And then fourth column means the index is 3. So you put it like this. This is what we have discussed. But I hope you remember in list processing we were discussing, so you can actually combine and type, right? So what happens here, if you use x2, you get the third row, and then within that one you will get the fourth element. So that's what you do here. Now instead you can simply you can say x, you specify row and a column like this, right? This notation might be very familiar. We were doing this in previous sessions when we work on the list processing. So you will get the same results. So the beauty is that now if you want to access third row, you can simply put it in this. Now, for example, if I put print x and the 2, and I hope you remember the colon where we have used from start to finish. Yes. So this is to get the whole third row. So likewise, if you want to get the row, the column, so let's say we want to get the fourth column, then we can put 3. So this is fourth column. This is third row. But you can get a submatrix if you want. Now let's say I want to get a part of it. I want to get the first two rows and first two columns, first two rows and first two columns. So I can just say X was, sorry, 3 rows. Well, let's say, okay, first 2 rows. So then it should be first 2 rows. Then it should be this 0, 1. That means it should be two rows. And then you need 2 columns. You can put it in this fashion. Yes, we are getting 1, 2, 5, 6. First 2 rows and first 2 columns. Sorry, these two, first 2 rows and then first 2 columns, which means we will get this part. Right. So basically, this is what exactly. So you might need to use, places like in an image. I told you, like, you can take a part of it. So for example, if I show you here, we have the image, and then image, I will specify like this, which I will get a part of the image. Right. So basically we can specify in pixels, starting pixels and end pixel. So basically the crop. So this is exactly what we will do. If you want to crop an image, take a part of the image. So image is a matrix, and then we can access a part of it. Right? So that's exactly, I have put it here, starting from 0 to 2. Right. Dr. Heyrat asked why the reason why index is 0 instead of index is 1. This is, sir, the answer is different programming languages use different starting value. Python start with 0, MATLAB starts with 1. So that actually depends on how they need to work on this. So Python uses 0 for simplicity because it's easier for you. Now, for example, this notation, I don't know whether you understand. So simply this is, I told you the first 2 rows and first 2 columns. So likewise, if you need first 3, then you just put 3, right? First 3 columns and 3 to 3. So that's their notation they have developed such a way that people can easily use in different contexts. So some may prefer to start with 0, some may prefer to start with 1. So that's actually when they have designed the programming language, they have set this. So in Python, it starts with 0. If you compare this with MATLAB, so that is one of the changes you need to remember. MATLAB starts with 1 and Python starts with 0. Okay. Right. I hope now manipulations also we have discussed. Reshape also I have discussed. Right. The changes. Now let's say you want to change a matrix. So I will copy paste this one for another. Right. If you want to change the elements in the matrix, it's easy. Right. Now this is what we have. Let me say print x. Right. And then let's say I want to change one particular element. You can simply say, let's say the first element. That means the index is 0 and 0. First row and first column, right? So let me make it to 10. Now next time, let me print it again. So you will see So it becomes 10, right? So likewise, let's say I want to change the row value, right? So if I put 3 comma colon equals 3, can you guess what might happen in the output? Any guesses what might happen in the output? So this is 0, 1, 2, 3. So you set this to 3, right? So if you run it, you will see here the first element is 10. Yes. Then fourth row, all the elements in the fourth row is 3. Similarly, if I put in this fashion, I'm actually changing the second column. I'm going to set it to 2, right? So if I do this, you will see that now I set this to 2. So this is 10, this is 3, and this is 2. If I want to change the whole matrix, simply you can say, let's say I want to initialize the matrix. So I can put colon, colon. So I get this. So this is simply how you may manipulate matrices. If you have any questions, I would like to answer. Otherwise, I would like to proceed. So let me know if you are ready. Put a message in the chat so that I can proceed.
Sampath, this previous question actually, why we start, I mean, I understand that different program use different way. Isn't it easy to go with like a 1, 2, 3 rather than like a, 0 means the first row, first column? Why? I mean, I know maybe there may be some advantage.
Yeah, this is exactly the answer to your question. So when you actually make the program, sometimes it's easy for us to start with 0 rather than 1. So that's why Python preferred 0 instead of 1. I know that it's,
but it actually, you say easy, but actually it's difficult, isn't it? Like, I mean, when you say 99th row, physically it is 99th row, but it is 98th row in the Python, isn't it? Yeah.
Yes, exactly. So until you realize this for some time now, for example, for me, it's not a problem right now because I'm now used to this. But for the newcomer, yes, it's very difficult in the beginning. I understand.
Yeah, no, like when we study these matrices, we say fourth row means it's fourth row.
Yeah.
But
I don't know. I totally agree. I totally agree.
No, I don't know. There may be some advantage. That's what I'm asking. Like in Python, for having like that. I don't know.
Yes. No, you will realize. I mean, like now, for example, when you just you don't have, so when you don't specify the start value, I told you it start with 0 and the end value. So they set this so that we can make use of it. But I agree that as you mentioned, sometimes it will difficult you to start with. I hope you are very familiar with Matlab, right? Are you using Matlab?
I use sometime. Yeah.
Okay.
Anyway, once we started to use this Python, then when we go and teach real matrices, then we may confuse again. Then.
Yeah, I understand, totally understand. But let me get back to you with a good example.
Okay.
Without that, I don't think I can convince you.
Okay. Yeah. Okay. Thank you.
Right. The next one that I'm actually going to do is some matrix operations, common matrix operations, how you may, use those. Now, for example, let's say we have matrix A simply I will put as np.array so I will have a list of lists. Let's say I have 1, 2, and 3, 4. Then b also equals np.array. Let's say we have 5, 6. Again, you don't have to type if you look at in the handout. So I have already typed this. You can copy paste if you want to just take the idea. Right now, getting the transpose is a dot p. So you can print, for example, a, and then transpose matrix. You can use a dot and put a capital T. So that's how they actually use it to represent transpose. But remember the one idea that we want to share, so you don't have to really worry about writing down the code. Most of the time, whatever the calculations you want to do, there are plenty of open codes are available. So if you know, so what you need is you sometimes need to understand what exactly happened in the code. Then if you have that background, so I hope that will be enough. So most of the time, most of the operations you might use, you don't have to write the whole code, right? If you have the basic understanding, I hope you can manage. Right, so element operations, we call elementary functions. So that means operation between matrix elements. You can simply use, let's say, adding a, b. We say add a comma b. So simply add the elements together. So a, b together. So 1, 5 will be 6. Then 2, 6 will be 8. And then 5, so 1, 5 is 6, 2, 6 is 8, then 3, 7 is 10, 4, 8, it will be 12, right? Element-wise operations. Similarly, you have subtract, multiply, division, that you can actually use it. Let me put up division, for example. We can say divide a comma b, so the division of it, the two matrices. And then if you want to get the element operations like the transpose, so maybe you can get a square root. So we can say print np.sqrt square root of a. So you get the square root of a. So here you will say square root of 1 is 1, square root of 2 is 1.414, and so on. Square root of 3 is 1.7 something, and square root of 4 is 2. But if it is real matrix multiplication, right? So we have to use dot product. So let me use matrix multiplication. So for that, you can use dot product. For example, to multiply the first 2, So we can use np dot, we can say comma b. So we'll get this output. So that is matrix multiplication. So dot method can be used for matrix multiplication. So getting mean values. Let me take my one of the examples earlier. Dr. Herat requests me the division of the two matrices. Sir, this is element-wise division. Element-wise division between A and B.
Okay, the first element is divided by
the first element of the second matrix.
Okay, okay.
Yeah.
Then okay.
So 1 divided by 5. So element-wise operation.
Okay.
So in MATLAB, you use dot operators, if you remember, for the element-wise. So likewise here, those are like element-wise operations. And for the multiplication, we use dot. So likewise, there are many others in the documentation, but I will here pick and choose, you know, assuming whatever import. Now, for example, mean values, let's say I have matrix A, let's say like this, np.array. I have used this earlier as well. Let's say we have 1, 2, 3. And then this example I have given in the handout. That's why I'm using exactly the same thing so that you can repeat this. So let's say we have a 3 by 3 matrix like this. Right. And then, okay, so I made a mistake here. This is 3 by 3 matrix. So let's say you need to mean of the whole matrix. So we can say that means average value of the whole numbers. So we can say np.mean, and we will say that means it add all the numbers together divided by the total number of elements. So we'll get the mean value. But you can take the mean value row-wise. Row-wise mean. np.mean. And when we say axis, 0. I will explain what axis 0 means. For the time being, remember that axis 0 will give you the row-wise mean. So if you look at here, row-wise mean, axis 0 is this one, the row-wise mean, and here the column-wise mean. So axis 1, that's how in Python.
Then what's the notation for the second column, column 1?
Can you repeat the question again?
But what is the notation for the column 1? Column 0 is axis 0, column 1?
Yeah, this is to say that if this is the matrix, so we normally say the index values are 0, 1, 2. And the columns are also, we say 0, 1, 2, 3, 4. This is 3 by 5 matrix. And then
So
when you
only
say
first row and first column can be defined by axis, right? Not the other columns and other.
Yeah. When you say axis, what you need to remember is it defines the row wise. So when you don't perform any operation only row wise, then we will say axis 0. If you want to perform any operation in the column wise, then we use axis as 1. Let me explain here. Now, in this particular case, the row wise mean, right? So that means row wise, if you add, we have 1, 4, 5, 5, 5, 10. 10 divided by 3, we will get 3.33. Then here we will have 6 minus 5, that is 1, plus 2 is 3. 3 divided by 3 is 1. And here we have 13, 16 divided by 3, we will get 5.333. So that means this mean value we get in row wise. So this is row wise mean. Now, for example, in a data set, if you want to get some feature averages, we have to perform in row wise mean, isn't it? Because assuming that all your data points in row wise, now to get the mean value, right? So the row wise mean, if you represent your data set as a matrix, so this is what we need to consider. Similarly, if you want to perform in column wise, so we put axis as 1. So here, for example, we have 3. When you add this up, row wise, we get 1 plus 2, 3, 3 plus 3, 6, 6 divided by 3 is 2. So here we have 5, 5 divided by 3, we'll get 1.66. And then we have 18 divided by 3, so we'll get 6. So it's column wise. Shobha Madam asked a question on how it is used in Fortran. So yes, you can write subroutine, but here is a built-in. Yes, exactly. The idea here is, madam, for all the metrics, common metrics manipulation, you can find the method. So it's a matter of finding a method to perform the operation you need. We don't have to write by ourselves. So only issue might be, trying to locate exact, function you need as a method in Python. So once you're familiar with use of different libraries, you will get the pattern. And then hopefully you can make use
So
of
libraries and commands are available, right?
Exactly,
Libraries
exactly,
and
madam.
there should be user manual.
Yeah, I mean, yes, there's a documentation, and sometimes when you type, you will see that's the documentation you are getting. Now, for example, when I say np.mean, when I put a bracket, so usually you get, this is the documentation is there. So you will see what you need to type, you can just type a, and axis is not mandatory, but you can provide axis, you can provide the data type. I think I have explained data type earlier. Likewise, everything is there, right? The whole, documentation comes when you just type it. And if you go down, you will see the examples. Look at here. So you have example as well.
Those days we used to find everything from the user manual and
No, I mean, you don't have to go there, madam. It will pop out.
Yes.
So you can find out.
Much easier.
It's easy. Actually, nowadays, it's very easy for you to, develop programs.
Do other things, the more advanced things when these things are available, right?
Exactly, madam. Yes, yes. Right. If you find with this part, then maybe I can, there are like functions like summation and the product. So that I will not going to explain. But let me quickly go to some numerical algebra equations that I have given, so that I can end up this part and move to the plotting part, right? So having said that, let me take the code window. I'm going to discuss solving linear equation like Ax equal B fashion, right? This is I'm trying to explain. So let me first of all show you the handout I have shared you. I have put down the equation. Now let's say we have x plus 2x equals 10, and then we have x1 minus x2 equals 7. We know that we can get these coefficients as matrices. So usually this will be A, and this will be X, and this will be B. Now, if you want to solve this, what you need to do is you define what A is, you define what a B is. So you have to define this part as A. So that means we can use numpy array. So we will have 1, 2, and then 1 minus 1. And the B, we have 10 and 7. And then we have a method, just you give you the solution, right? Right. So maybe I can also share two screen. So let me share the whole screen too. Yes. Then let me right. Okay. So I think this is right. Now, what we are going to do here, we are going to get these two equations, and then we have to show this, what exactly happens. Now for that, first of all, we define this A. So we will have A equals np.array, right? Now it's a 2 by 2 matrix. So we know that it's, we have defined the list of lists. So inside this, we have first 1, 2, that's the first row. And the second row is 1, minus 1, right? So you define A. And then next you define B. But remember, it's a column vector, right? So this is a column vector. So we will say np array. So we will have 10, and then we will have 7. 10 and 7. Now to solve this, there's a inside the numerical parameter numpy, we have a linear algebra, and there are a lot of methods. So let me explain that. So let's say the answers, let me say put it as x. We are trying to find x here. So we have np, and under np we have a linear algebra. So it's called ln dot. And then after that, you will see there are a lot of methods are coming in. So here are the whole list what we have. For example, we can find out eigenvalues, for example. So there are method determinant, right? There are a lot of things are here. But what we need is solve, right? Solve. And then you provide, so you also see in the documentation now, it says solve A comma B, right? So we put A comma B, simply that. And then we can print X. So when you run it, so you will get the output as X1 in our case as 8, and X2 is 1. So likewise, you can find out singular value decomposition, linear algebra. Like you can see when you put a dot in the documentation, you see the whole set of methods available for you to work on. So in previous case, what we have discussed is solving this. We have x1 plus 2x2 is 10 and x1 minus x2 is 7. And what we did is we put it as A and B. So matrix A with the coefficients of this. That means 1, 2, and 1 minus 1. Right. The B is, we have 10 and 7. So A is a matrix and B is a column vector. So we use the linear algebra library under numerical Python, and we use the solve method, right? Solve method. Okay. The last one under this one, what I'm going to do is, you know, how you may solve polynomial functions. Okay. We can solve polynomial. So let's say we have P1 equals x to the power 3 plus 2x minus 7, right? So simply you take the coefficients and you have put is an array. So simply as a vector. So that's the first step. So I'm going to say the polynomial P1. I'm going to define the polynomial as a using NP array with a list of numbers. So in this particular case, I will put the coefficients x to the power 3 is 1. You have to consider all the possible x values. So x to the power 2 is not here. That means the coefficient is 0. You have to put that 0 as well. Then for x, it's 2. And then finally, we have minus 7. Now, if you want to get the roots, you can use np.roots and then you put a polynomial. So this simply you have to use this. The roots 1 will give you the roots of a polynomial with coefficients given in p. So that we have to put as a p like array. Right? And then when you say print roots, I missed the commas here, sorry. So when I put a list, you have to put commas. So you'll get, you know, complex roots like this. At the same time, if you know the roots, you can generate the polynomial as a coefficient. So I'm going to make use of the same roots for this, right? That means, let's say, reconstructing. We can say print np.poly. So this method, you get the documentation, yes. Find the coefficients of a polynomial with a given sequence of roots. So basically with 1, so we will have the roots because we have used that one. If you use it, now you will get the coefficients as 1, 0, 2, minus 7. So you can see in this example, we have seen how to solve a polynomial, and given the set of roots, you can generate the polynomial. Now let's say we want to final one. Let's say we want to evaluate this polynomial. When x is 0, what is the value? So you know that it should evaluate to minus 7, isn't it? So this could be done like this. So evaluation, right? For example, in this case, we are going to calculate the value of P1 at x is 0. So we can say np.polyval, that is the method. Again, you will get the documentation. Now, I hope you are very familiar with the getting documentation. So you evaluate polynomial at specific values, right? Then you can specify the polynomial and then the value. So our polynomial we define as a coefficient as P1, and then the value we specify the second argument as 0 here. So then you will get -7. Right. So that's all actually I have planned to discuss under vectors and matrices. There are many methods. There are a lot of documentation books you can refer if you want to learn more. And there are nice tutorials out there if you're interested in learning more. But what I have planned here is to just to give you the bare minimum, your knowledge you need to, work with matrices, vectors and matrices in Python. Right, with that one, we conclude that part. The next what we are going to do is, Dr. Jailas asked whether I can recommend. Yes, definitely. I have a set of books. I will, share one, couple of books with you so that you can, So for example, the whole lecture series is depend on one of the books. I hope I mentioned this in my very first session. So you can actually access that one. Plus, there are many others. Depending on what area you want to specialize in, there are many methods. But I definitely share a couple of books so that you can continue the learning. Okay, having said that, any questions in this part? I hope you have seen the beauty of numerical Python library, where you can use many methods already available in the library for the metric manipulations. Right, now next one, for that I'm going to create a new one. So I will go back to create a new notebook. I will say create a new notebook. So I will name it, this is the Python workshop. Plotting, right? Because in this part, I'm actually going to use the plotting part. Now for that, I will plan to use the things we have learned from numerical Python, and then I'm going to introduce a new library. It's not really new if you are familiar with MATLAB. I hope everyone we are familiar with MATLAB plotting, and we are actually going to make use of same codes as we have learned. Right. Okay. So the two libraries you might need. So this is the first thing, is this one. So you have to import Matplotlib library. So there's a website you can go, matplotlib.org. So you can go there, and then you can make use of all the codes. So you can have a cheat sheet here where you can just look at simple codes. So for example, if you just look at everything what you need is here, right? So you see everything what you need is here listed, right? But I will show you a couple of things what you might need. Actually, the same library could use to manipulate images, although I have showed you different library in my example. So now you can many of them are using Matplotlib for manipulating images as well. But what I'm going to do today is very basic plotting, so that the other parts you can also learn from here. Right. Okay. So let's start. Under Matplotlib library, there's a a set of functions available under pyplot, and this is what we are going to use. And I'm going to rename this as PLT. I told you about this keyword as with PLT means for Matplotlib pyplot. I'm going to make use of this short. And then we have NumPy as NP, right? So first of all, you need these two libraries to work on. Right, once you've done this, let me define a few things. I will quickly go to the examples given in the handout. So for example, in this, we are going to use a range of values from -pi to +pi with the step of 0.01. I hope you remember a range function, right? A range function, you specify the start, stop, and the step, right? So start value, I'm going to say -pi. Stop is +pi, and the step is 0.01. Right, then I'm going to get the sign of x. So I'm going to define y as np.sign of x, value of x. Then now we have two, vectors. So basically we can now plot it. So the command is we can use plt.plot. So you will see the documentation. You can basically say x, y, right? At least you have to have one value. If you just say x, it will plot x. Let me just show you. X. And then if you say x comma y, so we are getting this. Simply, this is plot, x and y. To complete this, I will put this one. You might not need this, but if you run this in idle, you need this one as well. plt.show. In this case, especially when you use Python notebooks, you might not need it, not necessary. But remember, but if you run the same code in the Python idle environment, then you need this plt.show to get the output. Now, formatting strings, I hope you are familiar in MATLAB. Remember, in MATLAB, you have done this, the third argument. You can use a formatting string where you can define the color, for example, G for green, right? R for red, you can get from the documentation. Then we can also make the value. Now, for example, let's say I'm going to have triangles with dash lines. So I can update this formatting string so that we'll get something like this. We might not be able to see this because we have a large number of values. So let me reduce this, let's say to 0.3. Hopefully now you will be able to see because I made so that the values, the difference is set to 0.3. Now let's say if I put to 2, you will see. Yes, you can see how it goes. Let me put G. This is the code I have given in the handout, right? Simply, what we have discussed new here is this one. With the default one, you can say X and Y, but if you want to change the details, you can change it here. But when you use it functionality, you normally get this. So if you go to documentation, if you go down, so it lists all the values. You can read about this, the color, the markers, right? Then line types, right? And also the color values. Everything is included here. So you don't have to really worry about it. Now, for example, I can have magenta. So we can have magenta. Right. So simply you change this. So in our case, what we put is the green and then this V. Hat mark will give you a different one. So you can try out so a different way of putting the values. This is what we had in the handout. So I will stop at this point. So this is simply simple plotting. Right. Similarly, you can change this as I told you earlier. Let me say I'm going to put it as red. Now the color has changed. Yes, star mark. So here we have triangles. Star will give you stars. Right. Instead of dashes, I will have dash and a dot. You will see the line type has changed. Right. Now we have a different style. Then if you need more information in the plot, like the axis, you can use the same things that we did in MATLAB plotting. So you can specify the title. So for example, title is specified like PLT title. And then as a string value, let's say y equals sign of x. Like this, whatever you type within the string, it will display as the title. So we have the title. And then XY labels. So let me say X label. Yes, we have X label. And then we can have Y label as well. Yes. Now we have label x-axis and y-axis as well as we have provided the title. Then if you need a grid, you can just say PLT grid. So we'll get a grid like this. And if you want to specify, now here we have only one graph. When you have multiple graph, we have to show the legend as well. For example, here we have only one, but let me show you a couple next as an example. So you will get the output. Okay. There's spelling mistake. We are getting this output. Now the title, if you want to, have a slightly bigger font, then actually you can change the within this one. For example, I can, after title, we can put a comma, and within curly brackets, I can change the properties. If you want, you can change the font as well. Let's say I want to change the font size to 20 pixels. I can put 20. So I'll get this output. Okay, if you have any questions, please let me know. You can just copy paste the code I have given in the handout so that you will not run out any problems. May I proceed to the next one? Can you please let me know in the chat? Okay, next one is if you need like plotting multiple plots. In multiple plots, there are different techniques you can use it. So let me take another code window. Let me copy paste the code. I'm not going to spend time now. So let me explain the code. So in this particular case, the x we define as -2 pi to +2 pi with the step of 0.01. So a range, I hope you now remember. We discussed start, stop, and step, which will give us the array of x values. Then we will create 3 functions, y1, y2, y3. y1 will take sine of x, y2 we will get sine of x minus pi by pi divided by 2. And the third one we will have sine x minus pi. Now the first one is the plot command. Earlier we put only x and y. Now we have 3 values, xy1, xy2, xy3. So we will put xy1, xy2, xy3 as a single plot command. And then I put only legend to make sure that we'll have 3 lines to separate out the 3 lines. And then we'll say show. So if I run this, you will get this output. So in blue line, you will see the sine of x. Sine of x, the same command we have used in the previous example. Then orange color, we have sine of x minus pi by 2. And in green line, we have x minus pi. So you see that it's simply you have to use, plot xy. So remember you have to use the xy1, xy2, you have to provide the x. Okay? And the third one as xy. And next one, let me show you that one as well. Take the code window. The other way is you just, the second method, you will have separate plot commands. You will have separate plot commands. Now in previous one, we have single plot command xy1, xy2, xy3. Now here we are using 3 different plot commands separately, x and y, and the output will be exactly the same. Right. So that's how we will put up multiple plots in the same figure. Right. Okay. Then the last one I would like to discuss under this, there are many other examples you could try. And if there are any unclear places, you can directly write it to me. The next one that I would like to discuss is subplots. Right? There also I'm going to copy the code from the handout, and quickly I'm going to explain. Okay. Next one. Right. So the first one, like in the previous, we define x. So in x goes from -2 pi to +2 pi. The step is 0.01. Again, we have 3, functions. We have y1, y2, y3. If you remember subplot command, it divides the space, in this case, one row with 3 columns. And as the first one, we are going to plot xy. Let me explain with this one. So 1, 3, 1, what happens is the whole figure separate into 3 sections. One row, 3 sections, 3 columns. And the first one is this, which means the sign of x. Second one, when you say 1, 3, 2, again like this, we divide into 3, but the second one, we define it as sin x minus pi by 2. So if you run it now, you will see there are 2 graphs. Third one, right, the last one. Right? So this is what we will get. So basically, as I told you earlier, what happened here with the subplot command, it separate the figure into 3 parts. We said 1, that means the number of row is 1. So this is 1. And then we have 3 columns. This is the second one, 3 columns. Right? So this has 1, this is 2, this is 3. So the first one we will say 1, 3, 1. 1, 3, you have this and the first one. And this is the second one. And 1, 3, 3 is the third one. We will get this. And this is exactly same thing that we have discussed under MATLAB as well. If you are familiar with MATLAB subplotting, it will be the same. Right. Then bar graphs. Let me take an example. Instead of plots, now for example, if I have plot, we'll get this. Now instead of plot, if you put bar, so it will be the same, you will get a bar graph. Right? So bar graph, you will get this, you know, in this one. So you will say there's no space. So we have taken down the separate one. But you can change the array. You can define with different values. Likewise, pie chart. Instead of bar, we have pi. So you can have pie chart simply. You put up the values and then as a fractions, you will see as a pie chart. So you can actually change the look and feel and also the details, but I'm not going to discuss those as we have very limited time left for today. Right. Before I move any further, do you have any questions on this part? What we have discussed is the basic usage of Matplotlib library and use of plot command. We define X and Y, the simple plotting and also change of plots, adding details to the graphs.
I hope there may be chances and opportunities to put 2 graphs together and 2 combinations together. No?
Sorry, sir. I didn't get you.
Yeah, two types of plots together, like pie chart and a
yes, exactly.
plot.
Yeah, for example, here we have what? We have plot command. Instead of plot, let me put bar. Hopefully, we might not run into problems. You see that, right? That was the question.
Yes.
So you can change, yes. And you can, have the. So that those possibilities are, so if you visit the Matplotlib, right? So they are the library, and in the example, you can just copy paste these codes. So there are large number of graphs are here. So you can, play with those. So histogram, for example, I didn't discuss this, but now I hope since we have discussed the basics, you should be able to understand what really happens with this, right? So you can just use that code and you can do those. Okay. May I just finish the session with what I have to do as the last one? Maybe if we have time, maybe later on, right? Maybe during we don't have a break. Maybe dead week. Maybe we can have another session, or maybe afterwards we can think of. If you want to spend more time on the material that we plan to cover. But I guess now, since you have the basic, you should be able to, without any difficulty, you should be able to, learn more on, how to make use of Python. Shall I explain the machine learning application as well? Or is it too much for today? Okay. Yeah. Let me end our session with with a real example of use whatever we have learned today. I told you, like, especially what we have discussed so far is very, very important and useful, right? So I would like to conclude the workshop, right, with the machine learning example, and also I want to show you how you may use this. Right, so let me share my again, everything I have given in the handout. So plan is I'm going to basically show you the pointers where you can learn more. Right. Now, for the machine learning example, I'm actually look at the classification problem commonly arise in different fields. Right, in this particular case, we are, look at 3 different flowers. This is called iris flower problem. And if you just look at visually, the flowers looks the same, but there are changes. What the idea is, using the data set, we are trying to build a machine learning model which will automatically classify these flowers. So in data mining machine learning area, what we do normally, we start with the existing data set. That means we should have a already labeled data set, and then use that to build a model. I will show you what a model is. And then when you provide a new flower, our model should be able to identify the type of flower, right? Now, the first one, once you have problem, you should need to model this problem. So in this particular problem, what they have done is they have measured the petal length and width and the sepal length and width. They have measured these, and they have put up, collected the data about 150 flowers. So we set them, they have taken 50 from each different types of flowers, right? So the data set is simply like this. You have a numerical data set, and then you have different, classes, because I told you you need the labels in the beginning. So you have 150 data points, right? So this is how we can actually load the data set. So the libraries, we already familiar. The NumPy, we are going to use Matplotlib for plotting, definitely. And then the scikit-learn library, this library, it's a machine learning library available in Python. There are many others. And what exactly I am going to do is from here, I'm going to explain a classification problem. So those who are already familiar, you know that there are a lot of machine learning algorithms are available. Everything is implemented. Now, for example, linear models, linear regression models, everything is there. And then support vector machines, nearest neighbor algorithms, naive based decision trees, and also the ensemble models, quite popular nowadays. So everything is there, and even neural network models. You can use, many models like this, right? Idea there is using this, we should able to come up with our own model so that we can automatically classify the set of flowers we have, right? Now for the data set, I'm going to take it from their example data set. So dataset.load iris means I'm loading the data set as iris. So it will be a NumPy array. So I'm printing this. So when you load the data, data contains as a dictionary. I hope you remember dictionary. So you have a label item and then the values. So the item is data. So this is the data part, and it will be a numerical Python array. So it basically a matrix, right? So the dimensions are, if you look at, you will see you have a 150 rows, and then you have a basically 4 columns, right? The 4 columns comes in as these values, that is sepal length, sepal width, petal length, and petal width, right? Right. And then if you go down, next you have the target. I told you this is a dictionary. The second one, the item is target. And the targets are the name of the values. So that is also a numerical array. So 0 for setosa, then 1 for versicolor, and then 2 for virginica. So that's how it goes. Right, now what I have done here is I have separate these two values, data separately and target separately. Data separately means I'm going to put this data separately, and the target, this is what we want to identify, it's separated, right? So that's what we have in X and Y. And this is the first 10 rows. I hope now you know this notation. When you have colon and 10, it means 0 to 10. So you will get the first 10 rows, and then here the first 10 rows of the target variable. So that's a setosa. Then again, last 10 rows. So you have minus 10, right? So then it will give last 10 rows. Okay, visualization. Now visualization, it's easy. We need to use a plot command, right? We have to have plot command. So we have actually 4 values. Remember, we have 4 columns. Here we are getting actually the first one and the third one. We are taking first column and the third column. We have visualized, we have put it as the columns. So we basically get a scatter matrix where in X side we have the first column, and then the Y side we have the third column. Right. So this is how the distribution visually because this is a 4-dimensional data set, but we have selected 2 dimensions so that you can actually visualize the data set. So this is a visualization using a single color. The next one is I'm going to separate the data set, depends on the type of the flower. And in this one, what you see here is I have separated this into 3 categories: Setosa, Versicolor, Virginica. And then we have actually plot in the same. So what I did actually here, I have separated the values and defined different colors. So remember the formatting. If you remember the plot command, I have used 3 times here because for the 3 sets of data. And then first one I put red, green, and blue. So O means as a circle, it represents. Right? So this is the visualization. Right. Now, if you are not very familiar with, if you're not familiar with the training and testing, so in machine learning, what they do, usually you will have a training data set and test data set, and you create the model, right? That means the model later we are going to use it for classification. And then to test the performance of your model, you need some test set. So that's exactly what I'm going to do here. Now for that, we have to use the scikit-learn library. And for the model selection, we are going to split the data set. Now for that, we have what we call the train test split. So I'm going to split the data set with the test size is 0.33, meaning training size is 0.66. That means 2/3 of data I put as a training, 1/3 of data I put as a testing, right? So I have separated the data set as X train and Y train, X train and X test. So that is the data set. The labels I have separated as Y train and Y test. Right. Now building the model, again, this is from the scikit-learn library. I told you this is a supervised learning. Under that, we have decision tree for classification. And you can read on how exactly it happens, but let me briefly tell you exactly what will happen. In this one, we first build the model. That means we use the training data to develop a model. It will be a decision tree, right? So we use the decision tree algorithm from the library, and then we develop the classifier, right? And we will train the model. So in this one, we will fit meaning. We will provide the training data set as well as training labels. With that one, we will build the model. Now, once you get the model looks like this. This is a decision tree. So automatically from this training data, that decision tree algorithm automatically learns this decision tree. This is the model that I have discussed. So if you carefully look at what we have in the model is, first of all, in the very root node, it will check whether the petal length is less than or equal to 2.7. Whenever you get a flower, you have the 4 dimensions values: sepal length, sepal width, petal length, petal width. But it starts with the petal length. You check whether it's less than or equal to 2.7. If it is less than the 2.7, right, the decision tree identify the flower as setosa. Simple. You get the flower details. If the petal length is less than or equal to 2.7, the model is going to output that it's setosa. If not, what do you mean by if not? That means if the petal length is greater than 2.7, you check whether the petal length, whether it's less than 4.75. If that is the case, the model classifies the flower as versicolor. So you see at the end of leaves, you have the classification in the decision tree, right? Then, this is the model. So likewise, you can build neural network model. Unfortunately, you can't visualize neural network models yet. Then you can have regression models where you can actually visualize. So likewise, you can use any models you need. So there are arrays of models be available. And then you can check the accuracy, right? Now we know we have built this model, but we are not really sure whether this is capable of, predicting the data. So the trick is we use some test data to make the prediction. So this is how we make the prediction. And then we know the actual labels and we know the predictions, right? So we will calculate the accuracy. So in this model, it says 90% accurate. Then the misclassification we can look at by going through what we call the confusion matrix. If you are not very familiar with this, forget about this, but simply this is a matrix where I will show you the actual labels and their predictions. So the diagonal element represents the actual corrected classifications. Of diagonal elements, you see the misclassification. So you see that there are two misclassifications here, right? That means the first one predicted as the first one, and the third flower is predicted as a second flower, and so on. So you can actually identify where the errors are, right? So likewise, you can get some other outputs, the accuracy values to train the model. So then what you could do is, if you're not satisfied this accuracy, you can retrain the data, retrain the model, right, with different parameters. Once you're satisfied, then you can actually make this model for implement your real system, and then you can provide the new flowers, and then our system will predict the type of flower. Okay, that's actually quick 10 minutes explanation of this application, but you need to spend some time trying to go through each individually. So I hope you will spend some time on going through this to understand what I have actually tried to convey. And at the same time, if you have any questions, you can write to me, post me. And as I promised you earlier, I will share some of the books, couple of books, so that you can continue learning Python. Right. Any questions before we conclude? How many of you are familiar with this machine learning stuff? Dr. Jayala?
No, I didn't try.
Dr.
I mainly use Fortran and Visual Basic for
okay.
graphic designing.
Okay.
Actually, Sampath, my main interest of request in this is to image interpretation and video interpretation.
Yeah, we will have another session, sir.
Yeah,
but for that, please go through the numerical Python properly.
Yes.
Actually, I'm preparing a note set. I have not taught this, but this time I actually going to teach image processing for the third years. So hopefully, I need some time. Once I have prepared the note, I will have a session separately. As I told you, like what I showed you earlier is actually I was just trying out simple things in image processing with different libraries. So my final plan is to use in the scikit-learn. You have a image processing and video processing libraries, but definitely I will share. Right, I will have another session, but I have another book that I am referring. I will share that book with you, so you can right away start.
Please, yes, thank you.
Dr. Deepti?
Yes, Digal left. No, I don't have any knowledge about this.
Okay. So I hope most of you are very new to this. So maybe you can go through the example. And if you have any doubts, please, write to me, or maybe you can, talk to me. Yeah. And as I told you, I will share. Today, I'm going to quickly finish because I want to spend more time. But unfortunately, since we are starting the semester, I don't think I have 3 more courses this semester. So I don't think I can have a session. But yeah, definitely I will have a couple of more future sessions to go through this as Dr. Jalath request, we will definitely have a image processing one. Basically, we will manipulate matrices there. So whatever the things that we have discussed today is very, very important for that. So I hope you spend some time with this one.
But we can even analyze microstructures, right?
Yes, exactly, madam. There are a lot of libraries are there. So
Because,
if you can exactly tell me what exactly you want to do, maybe I can direct you relevant pages. So
we
maybe
have a lot of microstructure images of the same material, but different samples. So
okay.
even identification of steel materials may be possible, no?
Yeah, there are a lot of machine learning
lot of
applications in civil now.
yes.
I have seen even the books now publishing is especially in structural engineering. I have seen for analytics they are using.
For fracture, I mean fractography, we can have fracture surfaces and identify which kind of fracture it is.
Exactly, madam. So what we could do, I mean, if so we can actually give finally a projects, and you can supervise because you are the domain expert.
We
And
have data, yeah. So
yeah,
then the students can learn how to analyze
exactly.
them.
Yeah, maybe if we can discuss, maybe we can put it as some finally a projects, and we can try and see collaborate
Yes,
project. Yes, madam. So maybe I will contact you once we are going to have the next final year projects.
Yeah,
We'll put those. Yes, exactly. Yeah, then we
need
both
some
have
time.
some idea. Yeah,
Okay, we will
definitely.
do some with instructors and we can learn whether we can do things like that.
Yeah, you can do, madam, and I can show you like where you can actually start.
Okay, thank you.
Okay, thanks all day. So I enjoyed spending time with you, and hope you also enjoyed that. And some of them, not all of them, actually we taught for the first years as well. So which means for your second year, third year courses, you can easily now switch to Python programming. If you need any help, we have our instructors as well as I myself and the other lecturers in the department. We are happy to help you. But please let us know. I mean, sometimes we might not know how we could contribute in your programs.
Yes, Sampath, we have a lot of cases. I think Samal also still in the session. No? We have a lot of videos collected on traffic and transport, mainly transport.
Okay, sir.
Things like driver behavior, lane changing behavior, and then speeding, etc. And then mainly traffic counting. We do traffic counting manually these days. So if you can use a program to count at least number of vehicles, and it is good if you can classify and count, a lot of our work will become really easy. So if there are opportunities, we can think about working on a joint project.
Yeah. So Shamal, maybe you can contact your friends in our department, and maybe we could come up with some collaborative projects so that we can also develop knowledge. Now there are software available, but if we can have our own, I think we will know more about how exactly what is going on inside and so on. So maybe yeah, my proposal is, so maybe we could try some collaborative projects in aiming with final years. Most of the time we get projects from the industry as well as outside, but at least if we can have a couple of department collaborative projects, that might help both ways for our department as well as your department. So maybe we can plan for that, because now all the students know the Python and this material, they are very familiar with this. So we can, right away start, couple of projects on developing our own knowledge on these areas.
That will be really good. Yes.
Actually, this it is a trend now. So because when we see so many like journal papers, when we see like 3-4 authors, so one author is a computer specialist, especially programming specialist. So it is a kind of a world trend that most of our civil engineering projects are going as a collaborative with computer departments. So
Yeah.
always a programming specialist is there. So many joint works we can do together with this, programming technologies.
Yes, definitely. So yeah, as I told you, like I will take this as an opportunity to request everyone to have some collaborative work with our end. So in case I can be contact person in my department, there are like different person in different specialties in the department, so I can connect you. Maybe we could try a couple of projects and see. Okay, then I actually took 10 minutes more. Maybe we could finish. So I will send you some feedback forms as well as the video and the other information. So you feel free to request any more details. So having that said, so let me thanks everyone. Thanks for participating. And we'll hopefully see you in one more advanced topic with in Python.
Thank you, Sampath. It was excellent session. It was a very good way to start. Very good start.
Okay. Thank you,
we should be able to work. Yeah.
Yeah.
Thank you so much for your time also.
Thank
Okay.
you, Sampath. As beginners, yeah, it is very useful. So we have worked on it. So I think there are opportunities that we can use this in our research.
Yeah. Thanks, Rishika.
Thank
Thanks,
you.
everyone. Okay, then I'll stop for today.
Wish there were more participants, right?
Oh, no, madam, it's okay. I mean, like the idea is, we keep trackers as a recorded video. So if anyone wants to, learn from this, they are free to use the material.
Maybe Sampath, you can have a forum in EEU.
Yeah.
Okay, and anyone can go there and see these educational videos. You can.
Yes, that's the plan, madam. Exactly. We have been planning to have more educational videos, and this will be the start.
And Sampath, we also had some workshops on online learning, teaching, etc.
Yeah.
You can get those from the departments. Different departments may have done. We also did even Dr. Benaragama came and
okay, madam.
we did. So those resources you can share with others as well, I think.
Yes. Yeah, I will work on, madam.
As the director of EEU.
Yes, definitely. I will start that one.
And there will be no argument that EEU is functioning well.
Okay.
Okay.
Thanks, madam. Okay, then bye. I'll stop for today then.
You stay
Thank
safe.
you. Thank you, Sampath.